My name is Bill Wootters. I'm in the physics department, and I would like to say a few words about teaching. And I'd like to start by talking about the early 19th century physicist Hans Christian Ørsted. It is said that he discovered the phenomenon of electromagnetism while giving a lecture to a group of students. And I'm not sure whether this happened actually during the lecture or just after the lecture or in preparation for the lecture. I have found sources that say all three, and I haven't had time to find a definitive answer. But I would like to believe that it happened in the presence of students, because it's such a fun idea to think of being at a lecture where a major scientific discovery was made. I've never made a major scientific discovery in the presence of students or in a lecture, and I don't think that's going to happen in the rest of my career. But I think we can imitate one aspect of what Ørsted did, and that is to model for the students scientific curiosity. And a technique that I've used to try to do that is simply to, as I'm preparing for a lecture, to try to think of some questions for myself, questions that I would like to answer about that material. And I may not find the answer, I may find the answer. The questions may not come out explicitly during lecture, or they may. But I hope that by going through that exercise, my own feeling about the material is such that the students will pick up that I'm interested in it and that I'm asking questions about it. Sometimes it'll be explicit. I'll say, this morning I was wondering such and such. And maybe I have the answer, maybe I don't. But what I hope happens is that this will encourage the students to ask questions of their own. And that's what one really wants. One wants the students to ask questions. And any question is great, I think. And there are also, sometimes it happens, a student will ask a question and I simply don't know the answer. Even though I've tried to prepare, I may not know the answer, and I might come out of the lecture thinking, oh, that was bad, I looked stupid, and I didn't know the answer. But actually, maybe the lecture went very well because the student may leave the class thinking, gosh, I can ask a good scientific question. I asked a question the teacher didn't know the answer to. And that's a good thing for a student to think.
We can cut that out, don't worry.
Yeah, okay. The very best thing that can happen in a class, I think, is for a student to ask a question, and then in the course of discussing it, other students make their own contributions, and then it becomes clear that a large fraction of the class are really interested in knowing the answer to this question. And then I think it's worth taking some time out just to explore it, if possible, working out a calculation on the blackboard, even if it sets you behind schedule. That's the best thing that can happen, I think. It happened once last semester in one of my classes. A whole bunch of students seemed to be interested in this. We spent about half the class period pursuing this one question, still didn't answer it by the end, but then at the end, a lot of the students just stayed there and came up to the blackboard and contributed their own bits of calculation, their own ideas, argued about it. That's exactly what one wants. It's worth, I think, being set behind schedule a little bit when it happens. So I guess that's about it.